So now you will study about the force and pressure. So what makes things turn? The answer is turning force, right? So we'll see the first definition of the force. So force is a pull or push which can start or stop the motion of the body, right? Or change the direction or velocity of the moving body or change the shape of the body. So these many things force can do. So force is a pull or push which can start or stop the motion of the body, or it can change the direction and or velocity of the moving body or change the shape of the body. So these are the four main points it can do. Next is it is the acceleration experienced by particular body. So force is also type of acceleration. We know that F equal to ma from Newton's second law, right? So acceleration is experienced by the body, that is called force. And next point is force is applied to an object in a place, but it is not fixed in another. That is called fulcrum. The force turns it around the fulcrum, right? So it turns the position of the object when we are applying the force. When we open a door or tighten a nut with a spanner, we are exploiting that turning effect to that object, right? So when we are turning the or opening the door, we are applying the turning force. That is also the type of force. And with the door, fulcrum is the hinge. So at the hinge, we are applying the turning force. Next point is size of the turning force is also called moment. It depends on how far away from the fulcrum and force is applied. So that is called moment. So moment is nothing but it is force into displacement, right? That is called moment. So in everyday language, word pressure is used to express a constructing influence upon the mind or will. For example, we often say that we are working under pressure, right? So public brought pressure to the bear up the government. So in physics, however, pressure is measurable quantity that results from the application of continuous force by one body upon the another. That is called touching. Due to touching. So suppose force by area is called pressure. Pressure. So when we are applying the force on any object, right, having some area A, that is called pressure. So pressure is defined as force by area is called pressure. So write these many points.
So I have the notes for this also.
So in this chapter, we will study about the relationship between pressure, force, and area, and turning effect of the force produced in the fluids. Fluid means liquid or gas, okay? Or air pressure. It affects tool barometer used to measure the air pressure is described Boyle's law and application, right? So these many points we will cover in this chapter. So look at the diagram first. It is easy to cut the sharp edge of knife rather than blunt, right? Due to we know that pressure is forced by area. If area is large, pressure will be less. If area is small, so pressure will be large. So knife with the sharp edge cuts the fast because sharp edge is having less area. So less area will produce the more pressure, right? So according to this formula, P equal to F upon A. So this is the main formula applicable here. Now look at the next point, and understanding of the above ideas will help explain why it is easier to cut with the sharp edge of a knife rather than the blunt. Why dams are built broader at the base, while cooking food is difficult at higher altitude, and many such examples we will observe in this chapter. Now look at the main point, force. So force is a physical quantity which changes or tend to change the state of motion of the body or changes the shape, size of the body force can be described as a push, pull, or impulse, a stretch, or sequence. So this is the main definition of force. Or next point is force is a pull or push or impulse causes the body to move. So main purpose of force is to move the body from one point to another point, or a stretching or squeezing the shape of the body. Next point is force is a vector quantity. It is denoted by F bar. So it is having both direction as well as what? Magnitude. That is called vector quantity. So force is a vector quantity because it is having both direction and magnitude. So the absolute unit of force is, in CGS it is called dyne, and in MKS it is called Newton. Right. So read these points for the force. Now look at the examples. Right. So by pushing a trolley, we set it in motion. So when we are pushing the trolley, so trolley from rest get into motion, right, through the wheel. So in this case, speed of the trolley is changed under the action of the hand of the human body. So this is the first example. Now look at the second one. If we place a piece of iron or a stopper made of cork immersed in a water, then bring a magnet near it. Magnet will attract the iron and set into motion. So in this case, magnet is the body changing the speed of the piece of iron and stopper, right? So you can see that a push is hand caused by the trolley to move, and here in the case, if we push a ball by hand, a spring becomes compressed, or when we are stretching it, a spring get into motion. Right. Now look at the next point or next example of force. If we push a ball by hand, the spring becomes compressed and the end begins moving. When the spring stretch out, it also sets in the motion. So first hand was the acting body set in motion and end of the spring. Then the spring become acting body and set into motion. In the both case, when we are compressing it or when it is stretching it, in the both case, it get into motion. So in all the cases, what we have done, a body when acted upon another body starts moving, stops and changes the direction of its motion. So in other words, velocity of body changes under the action of other body. Thus force is the cause for the change in the speed of the body. Right. Due to change in the speed of the body is due to the force. Now look at the rubber band. Right. This is the book kept on the sponge. Plasticine is pushed by the hand. So in the example, so a force can be applied to change the dimension of the body and stretching and compressing it. Right, dimension, how it changes due to a stretching or compressing it. Right, so now look at the next point. Note, a force also cause a change in individual parts of the body. For instance, a, a board on which body is sitting, a boy is sitting, is deformed because the middle of the board shift to the larger extent due to its end. Okay, so due to its weight, it stretched, right? Because weight is acting downward. Now weight is mg, so mg downward force is acting. Due to this is a stretch. So these all are the examples of force. Now look at the next topic of force, that is called measurement of force. How you will measure the force. So first point is mass of the body is the total matter contained in it. It is the constant and expressed in gram. Or weight is the force of gravity acting on the body given mass. Right. So force of gravity is different for places at different distance from the equator. Hence the weight of the body vary as the distance from the equator also vary. Right. So we can say that mass is the scalar quantity, but weight is the vector quantity, na?
Vector.
Because it is varying with the distance from the center, right? Due to g vary. So we know that na weight is mg. So m is fixed, but g is variable, na? So when g vary, weight also vary. Now look at the next point. A spring balance is used to measure the force. Force or weight. Force or weight is same because we define force as ma and weight is mg. So here g is replaced by a in force. So both are the same thing. So this is called, a spring is called elastic. It is stretched when pulled and return to the original shape when the force is moved, provided the force has not stretched it beyond a limit. So at the spring is stretched, marker moves down the scale along the side of the meter, indicates the size of the stretch force. So this is your normal spring or a stretch balance, a spring balance. When it is stretched now, so we will experience the force of this much. So weight of an object is different at different distance from the equator, right? So this is the main difference between mass and weight, or force or weight, force or mass. So read this one. Now look at the next point, weight. So as I have told you that weight is also equal to force now, because A is when acts as a G. So weight is a force. It can be illustrated by simple experiment. Weigh a small object in air by spring balance. So weigh the same object after submerging in water. So object is found to weigh less when submerged in water. So this is because the water exerts an upward force, up thrust, that effectively lessen the downward force of gravity, right? So on Earth, mass of 1 kg is nearly 9.8 Newton, because W equal to mg. Suppose 1 kg and g is 9.8, so it will be approximately equal to 9.8 Newton. So unit will be same for weight and force. So you can written here 1 into 9.8. It is 9.8 Newton no? For 1 kg. For 2 kg it will be 9.8 into 2. For 3 kg 9.8 into 3. So like that we have to multiply with the 9.8 only. Right. So the setup is made here. So a body is hanged with the stretch, a spring balance, or and when body is tied here and it is dipped into the water, so this upward thrust is filled. So this will give the variation in the weight, right? And this is done by the Robert Hooke, inventor of the spring balance. So Robert Hooke discovered the amount of an elastic body stretched out of shape in the direction proportional to the force acting on it. So as long as the force is not large, the spring will go back to the original length when the force is removed. So this is done by the Robert Hooke, right? So now we'll understood the pressure definition. It is force per unit area, that is called pressure. So force unit is Newton and area unit is meter square. So P will be equal to F upon A, right? So this is the formula for pressure also. Now look at the cases for the pressure. So let us illustration of A and B. So a force of thumb, right? Surface area in contact. So when we are applying the force on this nail part, so pressure is exerted by it. So pressure is force by area, right? So now look at the here force of thumb, surface area in contact. So pressure is defined as force upon area in contact. So you can see in the both diagram, if you try to push a pin with the pointed in through a cardboard sheet, it will emerge out through the easily. And if we try to push a pin with a rounded bottom through the same cardboard, we may have to push very high, right, due to larger area. So as I have told earlier that when area is large, pressure is very small. And when we are keeping the area small, we get the larger pressure, right? Because they are both inversely proportional to each other.